Mic check. We are on. And we're going to be live streaming, talking about Black Friday, Cyber Monday this whole weekend, doing commerce on Vercel across the internet. And I want to show a website we built to show some of the traffic live, some of the action our firewall is taking, and also talk through how our network works, have a chance to chat with y'all and just interact in the chat. And also shout out some of you who are building on Black Friday, who have deals, indie makers in our community. Would love for you to share your deals, your specials, and amplify them here for others in the Vercel community to check out. So that's what we're gonna talk about today. Just getting things live right now. I'm gonna kind of amplify it out on socials, and then we'll get started taking a look at this dashboard that we've created. So let me go ahead, tweet this out. And if you have links to things that you're selling on Black Friday, Cyber Monday, please do share it in the replies. We're gonna be live on X, YouTube, LinkedIn, Twitch, everywhere, and you should come hang out. You should definitely come hang out. Okay. Going live now, posting on X. Okay. How's everybody doing on this fine Saturday? Did anybody buy anything already for Black Friday, Cyber Monday? I actually bought something, which I'll talk through a little bit here, which is kind of funny. I got a laptop skin. I've always covered my laptop with a ton of stickers, but I actually pulled the trigger, got a laptop skin, one of those nice branded skins, and I'm excited to try that out. I think it's gonna look pretty nice. Let's see. I am going to do a little quote tweet action here. Okay, we're live on the X platform. What about LinkedIn? Let's go live on LinkedIn. And then I think we're ready to kick things off. While I go ahead and do this, I'm just gonna put this up so we can stare at it and enjoy the beauty of our live tracker while I get things streaming and ready. Okay, LinkedIn is up and live. Let me see if I can. Okay, that looks good. Ready to rock and roll there. Awesome. Change this. Okay, LinkedIn is ready to go. Yeah, drop a comment in the chat where you're tuning in from, whether you're on X, LinkedIn, YouTube, Twitch. Would love to hear where folks are watching or shopping their Black Friday, Cyber Monday from. We'll post this out. Okay. LinkedIn is done. Now let me do Twitch. We'll get Twitch live, and then we're rocking and rolling. We're ready to go. Okay. I think we are now ready to kick this off. So what are we even looking at here? What do I have pulled up? Well, there's a couple things. First off, I have this dashboard on the left, which is something we built just for Black Friday, Cyber Monday. I'll actually give it a refresh here so you can see this nice loading sequence. It's got like a boot up screen. It shows our edge locations, all different points of presence, and then live traffic, including requests and number of deployments from all of the different edge regions in Vercel's edge network. And you can even see the breakdown by country and some of the firewall activity as well. So I'm just gonna kind of keep this up as some background vibes as we talk through a few select choice articles that talk about how our network works, about how our firewall works, answering questions in the chat that you all have about Vercel or about Black Friday. And also, like I mentioned, if you have a Black Friday, Cyber Monday deal, you're an indie maker or a builder on Vercel, please comment on this video, drop a link in the chat. Would love to find a time at the end here to amplify some of the things that y'all are building. So that's what we're gonna do today. I've got a few kind of choice articles picked out that I would love to talk through. And yeah, let's do it. Let me check on the chat real quick. See how y'all are doing. Hey, everyone. Nice. Thanks for hanging out. Got some people buying domains today. Nice. We could talk a little bit about V0 as well. That'd be fun. Some folks tuning in from India. Let's see. Want to know the tech stack behind the live dashboard. Built something similar a few years ago. Yeah, we're going to talk a little bit about that. It's built end-to-end on the Vercel stack, and we're going to talk through some of the technology used there. And did I see the other Black Friday sites? Yes, I have. So there's been a few for like commerce and payment providers. I feel like have done a good job of a similar way of kind of amplifying the work they're doing on Black Friday. And I think the one that I probably liked the most, Stripes this year, is very cool. They literally built hardware to power the site, which I think is really cool. I can link out to that as well. But yeah, we wanted to enter the chat and also do something fun to celebrate all the folks building on Vercel that we're powering this weekend. So that's kind of the origin story here. And I figured, it's a good time to talk through how our edge network works, how our firewall works while we're here hanging out in the chat. And also fun to answer questions from you all. So the first article I kind of wanted to read through to set the foundation before we get into some of the others. As I mentioned, I've got kind of a few choice articles here we can talk through about how the life cycle of a request on Vercel, how our firewall works, and so on. But first, I want to set the framing of kind of what Vercel's edge network is really giving you. And it's this broader category that we talk about. Vercel is a front-end cloud. So we've got this post. We're going to start here. I'm going to be available to answer questions if you're like, Lee, I don't understand that part, or you want me to go deeper on any of these. So let's just speed read and get into this. Web apps today are judged on 6 core principles: speed, global presence, scalability, dynamism, reliability, and security. Users and businesses expect excellence in all of these. Yeah, people want fast sites. User experiences have become more engaging and dynamic. CDNs and infra as code, which have been popular for some time, there's some challenges here. CDNs, which are designed for static content, you can think about it like you've probably pulled a jQuery instance off of a CDN at some point. Just doesn't really match the needs for kind of dynamic, personalized, real-time applications. They can do some things well, for sure, but Vercel's edge network is more of an application delivery network, and there's both static and dynamic content. I'm kind of going off track here, but that's the fun part. At the same time, infrastructure as code has programmatic code management, which is nice in some ways because you can check this into source code, but it often ends up with teams spending a lot of time building their infrastructure, which I'm sure a lot of you have been on teams where you got stuck kind of managing the infra as code, or you had a very small DevOps team that was managing that work, and there's always more infrastructure work to do. And that leads to this kind of bespoke and complex infrastructure challenges that I've personally had to deal with in the past running my own applications. So as the web has kind of evolved, one thing that we're calling the general category here is a front-end cloud that tries to abstract away some of this infrastructure and make it easier to deliver dynamic applications. So let's talk about this static to dynamic web. When the web started, everything was pretty static. And static in the sense of we were delivering HTML documents. You weren't really running like dynamic web applications. Google Maps wasn't available yet. You weren't doing complex e-commerce websites. Content wasn't frequently updated, and you were probably dropping in, SSHing, and pushing something to your server, which, hey, you can still do that if you want. There's nothing wrong. Nothing wrong with that approach. Also, webmaster is just a completely goated name for a job title. So if you're a webmaster, yeah, just shout out to you. If you've ever had the title of webmaster, you've seen some stuff. You've lived a life, and for that respect, W's in the chat. With the rise of JavaScript, tools like jQuery and Ajax made it more possible to create apps, like Google Maps, and really led to this new era of dynamic web applications. Now you had one role that was focused on UX and another was focused on systems infra. So then we had frameworks like Django, Laravel, Ruby on Rails that made it way easier to kind of build the server side of these applications. Not only did they make the DX easier of actually scaffolding a lot of that infrastructure, but they were very pragmatic and just tried to help you build these type of applications. But again, they kind of got this split into front end and back end, and you were staffing these roles independently. I mean, as an aside, I think for a lot of folks who have worked in front end, you've kind of felt like it took a while for the industry to really feel and validate the importance of building front end applications as a, quote unquote hard engineering problem. There was actually a lot of stuff there, but it kind of got chalked up to this kind of web experience interface builder that was just pushing HTML for a while, but the complexity of those apps, really grew a lot. And then the connective tissue between those was DevOps. So with the growth of CDNs, which became really popular for, caching and delivering those static assets, all of a sudden things really shifted into these dynamic web apps. You weren't just serving up the same cache page on every request. You wanted to personalize it based on the user, their past shopping history, especially relevant with Black Friday, Cyber Monday. And that just wasn't really compatible with the kind of cache everything model. It needed to be more granular than that. So they struggled with real-time dynamic data. Dynamic web apps using SSR, developers had to rely on setting these high cache control time to life values. But that would lead to caching a whole group of pages, which would be frequent data changes that could be slow or unreliable purges. I will say, like, most CDN infra has gotten better at the purge pipeline and the reliability of that. The tricky thing is that it gets out of hand really fast if, one, you're trying to manage this yourself, or two, you have really, really large applications. But it's kind of a non-starter if you have more granular than entire page caching. Even with advanced settings like vary cache control headers and surrogate caching keys, which are relatively new in the grand scheme of things, the cache remains too static, causing high cache misses. Okay, I feel like this is a big one, and for those of you who have been in the Vercel community for a while, this was part of the original genesis of Zeit, and now is, it was hard to do distributed systems on localhost. Like, how do you replicate a serverless or a global infrastructure or a CDN at the time kind of on your local machine? Well, there wasn't really this tight pairing of framework and infrastructure that can give a lot of benefits here. So local development with CDNs has kind of always been challenging. You want the same behavior on localhost in a lot of time, so you can mimic and understand what the behavior is going to look like before you go to production, especially when you're trying to figure out caching, which is, definitely can be difficult. Without a staging or preview environment that mirrors that real world behavior, devs can have issues like stale content, cache misses, or incorrect purging. You want to have ideally that same kind of purge pipeline replicated locally. So certain features like cache invalidation, CDN routing, or edge side includes, throwback, just are hard to replicate locally. So testing and previewing that was pretty hard. I think there's been some solutions that have done this okay, but it's definitely a tough problem, and there's some foot guns. So as a result, CDNs can sometimes feel like shipping the org chart. Yeah, I think one thing that I've seen, in talking to a lot of teams here, is that it almost becomes a thing where a security team will purchase the CDN stack, and then the developers, the application developers who are trying to think about the system holistically end to end, have to kind of go across the org chart boundaries to get get what they need out of their infrastructure, when ideally they want to have more control over the end-to-end experience of that application delivery. So this is such a good point. When you're blocked by the org chart, what do? You just work around it. And what can you control as an application developer? Well, if my only solution is I've got some global security policy that only allows entire caching of pages, I can't do anything more granular, well, I'll just do it on the client side, right? I'll just make the page serve up a kind of blank shell or a very minimal shell. And then I'll load client JavaScript, and the client JavaScript will do the personalization, the real-time updates, the experimentation. But this is bad. I think we all don't like this as the web, has kind of evolved in this direction over the past, let's call it 10 years. These experiences suck. They're not fun. This is how you get, flickers and flashes of layout shift. This is how you get bloated JS payloads. This is how you get flags of feature flags when something's on and then it flags off because it had to wait and load on the client side. It's just not great. There's a whole category of solutions to this, namely with servers, where you can send this work to. That's pretty much exactly what it said here. Especially on slower networks. Yeah, those folks are really the ones who pay the price more than anything here, is because if you're loading that kind of massive JS bundle, it's not going to be fun if you're on a slower network or a lower powered device. Despite aiming to create the best user experience and deliver business values, companies often spend significant time on undifferentiated technology and infrastructure. Yeah, you reinvent the wheel a lot. Okay, meta frameworks and the front-end engineer. So JavaScript and TypeScript has gotten, of course, pretty popular in the last 10 years. There was, some trials and tribulations there trying to figure out what the future would look like. Was it going to be TypeScript? Was it going to be Dart? Was it going to be something else? But TypeScript is definitely one, and there's been 1,000 flowers blooming of front-end frameworks, all the way from Next, which of course we work on at Vercel, but to newer things like TanStack and Astro, Nux, SvelteKit, Remix, Vite, Gatsby, all sorts of things that allow them to take advantage of the server, right? We still have some things on the client that are good, but we also want to use the server for things that it's, specifically good at handling. And this really empowers that front-end developer to be increasingly more of a full stack, or as I like to think about it, a product engineer. Especially with AI, these folks are spending a lot more time on delivering product value, shipping actual features, not necessarily doing boilerplate, communication over the network for front-end or back-end traffic. These engineers fluent in TypeScript, not JavaScript, TypeScript and AI are really powerful now. I have a blog post on my blog called Product Engineers if you want to see a little bit more on this. Okay, core principles of application delivery. I'm going to pause here for a second because I have been yapping for some time now. And I want to see, again, if you have Black Friday, Cyber Monday deals on Vercel, please let me know. I would love to see them. I would love to shout them out. Beansmate and Twitch, what's up, Lee? Thanks for hanging out. On LinkedIn, we've got some folks hanging out as well. Can we have React 3 Fiber and V0? You absolutely can. If you just ask it to create a 3D scene, it should probably use that. Jesse on LinkedIn, we bootstrapped everything on Vercel, changed my life. That is awesome. I am so happy to hear that. Your salespeople will start building products now too. Yeah, absolutely. Some of our sales team are very proficient V0 builders, actually, which I find very fun. It lowers the barrier to entry of people creating software. And I've talked quite a bit about, and G's talked a lot about personal software, which I think is so cool. Just building software for yourself that you're empowered to do because you now have skills that maybe were difficult in the past. Maybe you weren't a TypeScript expert and you couldn't figure out that generic, but now it's just a lot easier to do that. Let's see, on X, we do have, not a Black Friday, Cyber Monday deal, but .netinterviews.com was built with Vercel. That's awesome. Yeah, can't thank the team enough. Thanks for sharing that. I'll give one more shout out. If you have Black Friday, Cyber Monday deals, please let me know. Would love to amplify those. And our total requests are still going up and to the right. Some of you are deploying right now and making our counter go up as we speak. But let's keep rocking. Let's keep rocking and rolling. Critical piece of the puzzle that remained, infrastructure. Infrastructure, still hard. Even with good frameworks, still hard to do infrastructure. And there's a couple things that you wanted with your infrastructure. You want it to be fast. It needs to be aware of your framework, ideally. You want it to be global, so you can have it close to your users worldwide and minimize that latency as much as possible. You want it to be scalable. If you have a traffic spike, like Black Friday or Cyber Monday, ideally you don't need to have, an on-call DevOps team that is scaling up Kubernetes instances because you dropped a promo code take or something. Like you dropped something and now all of a sudden you got this huge spike of traffic and your site's down and you're losing sales by the minute. I remember, I used to work for an e-commerce company and it was very easy to quantify. Like any second of downtime is X number of dollars of revenue lost. And that is incredibly painful on the biggest shopping weekend of the year. So scalable is really huge here. Scalable and reliable, because downtime is kind of unacceptable here, which is not just your infrastructure scaling up, but it's also things like a firewall that's going to prevent bad actors because inevitably there are people who are malicious, which kind of ties into secure. And then, dynamic. The best, most personalized Black Friday, Cyber Monday experiences, e-commerce experiences, really any web experiences. They know about the visitor. They know who you are. They give you content that's relevant to you right away. And that's going to take something that's a little bit more fine-grained than all or nothing page caching. Okay, framework-defined infrastructure. Front-end devs need something that kind of lends into this front-end cloud experience where you're writing frameworks and then you deploy it to some infrastructure. So our front-end cloud, for example, what we talk about is framework-defined infrastructure. What this means is I write code in Next or SvelteKit or any of these modern front-end frameworks. I'm not necessarily writing infrastructure-specific code. Like I'm very rarely having to go tweak the knobs of the infra that gets created. I didn't have to do infrastructure as code. Instead, the framework outputs the infrastructure for me. The framework has this kind of adapter pattern where Vercel is able to understand that and in the build process kind of scaffold out all of the cloud infrastructure needed. So I write a server rendered page, I write an API route in any framework, and Vercel is able to then transform that into Vercel functions, which is our kind of highly scalable, reliable compute. And we can talk more about that as well. This chart's fun. Back in the day, you would SSH into a machine. Of course, you can still do that. The CI/CD pipeline got a little bit better where teams are shipping on, a higher cadence more frequently. Infrastructure as code not only made this easier to deploy code, but also added more of kind of an audit trail for how you're making changes to your infra versus going in and just manually making changes without any kind of security back trail. And then I think, and we started to see other companies, other kind of adjacent solutions to what Vercel and Next are doing, kind of think about this co-evolution of how the framework works and the infra works together. This isn't just applicable to web apps. There's other fields where I think this makes a lot of sense too, but this type of pattern, which we've called framework-defined infra, I think makes a lot of sense, especially as we kind of blur the front end and back end to be product engineers in building with TypeScript. Front end frameworks and their infra evolve together. The way I like to think about this is on Vercel, like the relationship with Vercel and Next. Vercel is where we are kind of dog fooding and testing out new ideas when they're experimental for our own internal usage of the framework, and then working with select early partners to figure out what patterns make sense, what RFCs we want to push forward, and so on and so forth. We're innovating here, and then we bring that innovation back into open source and make it accessible and available for the entire community, whether you're on Vercel or not, whether you're self-hosting or on a $4 VPS, which I have a video on if you want to learn how to deploy to a $4 VPS. It's on my X, it's on YouTube. That's kind of how we think about that relationship. Front-end clouds address some of these limitations of kind of static CDNs. They're aware of the frameworks. They have their reproducibility on localhost. You're just writing framework code. You're not writing bespoke infrastructure as code. And if you want to understand how cache invalidation works or routing or how you handle dynamic content, it's what the framework is doing. So the framework is going to have concepts built in for caching, whether that's just using cache control headers or something more advanced, like the use cache directive in Next.js. That's an upcoming kind of composable caching solution. We have a nice little diagram here. So the front-end engineer is thinking about everything across the presentation and the logic of the app. You could also call this a product engineer. Then I would say increasingly front-end clouds are abstracting away a lot of the infrastructure work and providing a managed solution for kind of scaling and managing the cloud infra as well as the security in your application. Not just Vercel, but I think there are other solutions that are doing this well too. And yeah, that's pretty much it for just in general how we're thinking about what a front-end cloud is, kind of why CDNs are good for some stuff, but generally on Vercel with an edge network, as you can see here with our kind of 18 points of presence, or sorry, our 18 edge regions and many points of presence here. This is kind of how we think about our front-end cloud, how we think about our edge network, and how we're optimizing for global application delivery. So next one, let's talk about what happens when somebody goes to a Vercel website and the user presses enter. But first, let's check out the chat. What is up, chat? Any other questions or things you want me to touch on more while I'm here? Got a shout out for the self-hosting video. That's awesome. Glad to hear it. That's on my YouTube if you want to check it out. Okay. Let's keep rocking and rolling, and we'll start on this next blog post. Let me just check. Okay. Let's talk about what happens when a user presses enter. Thank you, Dan, for writing this blog post. We're going to talk about application delivery. So this kind of, I feel like it is kind of building off of the last post, and then we got another one after this. Lots of good content that will extend this even further. So when devs push code, whether through the CLI, they push it up to GitHub, Vercel's framework-defined infrastructure kind of looks at the code and figures out how to provision the cloud resources. So we talked about this a little bit. Now, when the request comes in, Vercel's infra is going to route them to the nearest data center over high-speed, low-latency network. So that's all of these popping triangles here. Those are the edge regions. And first, it's going to get routed through the points of presence before going into those more dense regions where we can have a higher cache hit ratio. So let's talk about it. The on-ramp to high-performance application delivery. So when users access apps served by Vercel, their network requests are handled by our dedicated network. So this isn't some, shared network across, many different ISPs that we're peering with. This is, high quality fiber that is fast, hence fast data transfer, scalable, redundant, and also has, we can talk about multi-availability zone failover, there's regional failover, all sorts of things that we're doing to try to help make your application safe and secure and reliable. Here is another diagram of our edge network, which is the static version of the one on the left. So let's just use the one on the left. Anycast routing directs the request to the optimal point of presence. Shout out to Anycast. Across 100 plus global locations or POPs using the proximity and the live network conditions to minimize latency. So if I make a request, close to one of our European POPs, for example, we're going to route there versus if I'm in the US. And it goes through this congestion-free, fault-tolerant private fiber. That's what I was talking about with, kind of a high-quality network line that we're building on top of. Next, we secure your app's entry with the Vercel system firewall. The Vercel firewall, there's the system firewall, and then there's user-defined rules. And we'll talk about both of these. So requests reach Vercel's edge network at that point of presence layer, and they go through multiple stages of our firewall. So we're trying to protect you as much as possible, especially on weekends like this where there's lots of traffic, there's lots of folks who are, potentially trying to make malicious requests. And we can see down here in the bottom left, over 1 billion system blocks already, which is awesome. Challenges, which it's not blocking, but it's basically saying this request looks sus, and I'm gonna show it the challenge screen first. Our web application firewall blocks, which are things that users define, and then just total actions in general here. So that's kind of fun to see. Actually, I'll leave this scrolled down because that's nice. So at the POP, they encounter this firewall kind of multi-layer defense system. So this is layer 3, layer 4, and application layer 7. And this is both the Vercel kind of managed global rules, but then also the custom defined rules that you had. So the first one kind of looks at all the traffic across your deployments, and it blocks L3 and L4 threats. So DDoS attacks or DOS attacks, SYN floods, UDP attacks. These things are things you don't want to deal with. They're not things that you want to manage yourself, and they can cause downtime if somebody's trying to be malicious to your application. Luckily, because Vercel's network has seen hundreds or thousands or millions of these types of attacks, then it's able to learn and intelligently get better at preventing and protecting you based on different attack patterns that we see. I think we have another post on that as well, which I can read. So then requests get routed in milliseconds to one of the 18 global edge regions. This mitigates risks like HTTP floods, or I don't even know. Honestly, I don't even know what this one is. Slowrorus. Somebody, Dan, you're going to have to tell me what this even means because I don't even know what this means. Slowrorus DDoS attack. Okay, here we go. It allows a single machine to take down another machine's web server with minimal bandwidth and side effects on unrelated services and ports. It tries to keep many connections to the target web server open and hold them open as long as possible. Interesting. Okay. They should call it something like Slowpoke. We need a Pokemon related name here. But yeah, TIL. Did not know about that one. At this point in the request lifecycle, system level firewall protections have enforced our enterprise-grade attack mitigations. So we block, just to give you kind of a sense of scale, 1 billion malicious TCP connections every week, probably more now since we've read this, and that's just all things you're not going to have to worry about, taking your site down or causing you unintentional usage. Okay, requests go through the edge regions, they pass these defenses, and now they're aware of your application. So now they have the full context of your deployment, your security logic, your routing decisions. And this is where the framework-defined infrastructure, the framework code comes to life. So now that we made it through there, we can talk about the application code. There's one last thing. There's one more thing, which is the web application firewall. This is where you get to define your custom system rules or your custom user rules that are different from the platform-wide firewall. So if you want to block based on some IP address, some fingerprint for the incoming traffic, some rate limit, you can do all of that both through managed rule sets that we provide, but then also through your own kind of custom rolled rules. So if I want to block a specific IP because I go look at my firewall logs, I can totally do that. You have full control over this, and updates get propagated around the world to all of the different edge regions in Vercel in about 300 milliseconds, which is awesome. Okay, now we're into kind of the framework level or the framework aware parts, which are things like middleware, redirects, rewrites. These are things that are running before you're doing the rest of the kind of processing of your application. We've pulled them up and put them in the edge regions so they can run closer and they don't have to go back to the origin. So, ideally you want to terminate that redirect as fast as possible. There's no need to go all the way back to potentially an origin compute region in US East or somewhere else if you're just saying, hey, blog 123 needs to redirect somewhere else. So those can get hoisted up to the edge regions. These can be pre-configured in your framework code. And then there's also the ability to write dynamic redirects, rewrites, and headers through middleware where you kind of have full control over what you want to use. This can be business logic as well too. So you have, full control over that control flow, whether you want to do if geolocation this, then go here. You have the full ability to kind of drop down into code. So here's kind of a little visualization of how that works. That's pretty much this. We also support doing micro front ends, which we have a nice blog post about how we adopted micro front ends, if you want to check that out. Caching the edge to speed up experiences. This is all good stuff. And I'm going to pause and again check the chat, see if there are any shout outs to folks on Vercel who have Black Friday, Cyber Monday deals. If you're an indie maker, if you are on the free tier, if you're an enterprise customer, I would love to hear your Black Friday, Cyber Monday deals, and I will give you a shout out. So let me know. Let me know. How's Twitch? How's LinkedIn? How is X? How's YouTube? Doing good? Doing well? Okay. I see the chat is bumping. Love that. Okay, caching at the edge. Caching at the edge to speed up responses. Caching is great. We love caching. And as I mentioned, there's nothing, having full page caching It's good to have for some things. The problem is that it's a very heavy hammer. You can't apply it to everything. Sometimes you want to have more granular caching when you have personalized pages. So we go through the router and then we hit our edge cache. As I mentioned, we have kind of fewer, more dense edge network regions, 18, so that you can have a higher cache hit ratio versus having, say, 100. Instead, for the larger number, we have more pops that are doing the kind of TCP termination first before going to the edge regions. Data is kept current through updates and revalidations based on the content status. So your content can be fresh, stale, or regenerate in the background using something like ISR on Vercel, incremental static regeneration. This can be things like images, CSS files, JavaScript files, or even API responses as well. And this is kind of how you can visualize the edge cache where content responses to some request, whether it's images or files and so on, can be stored and revalidated or regenerated. Okay, next up in the life cycle of requests, you've made it this far. Hang with me here. We're getting there. Now you hit the compute. So compute on Vercel is called Vercel functions. And this is the special sauce that allows you to run that dynamic personalized code. So you need to talk to a database. You need to go talk to an external system like a CMS. You have to run some compute, go talk to an AI model to do some inference. That is where Vercel functions come into play. And they get automatically managed, provisioned, spun up, spun down, auto-scaled, cold start prevention, all of that great stuff with no user effort on your side. You just write your code in the framework way, whether it's a React Server component that runs dynamically or an API route in Svelte or a loader in Remix, so on and so forth. That gets turned into Vercel functions on our network. Now, it's worth talking about the placement of Vercel functions. You want to place your functions close to where your data source is. This is different from the edge network regions where you're placing those. Those are located close to your visitors because you want the network round trip between your database and your compute, which is probably going to be pretty chatty. There's going to be a lot of traffic there. You want that to be minimized. You don't want to have to go, across the ocean every time you need to go fetch something from your database. So you might have 1, 2, 3 maybe regions where you have your data and you want to co-locate your functions with that data. Side note, we recently announced the ability to have multiple Vercel function regions if you do have globally distributed data. So that's a nice little thing to have. Our Vercel functions, we have a nice blog post that somebody wrote named Lee that talks a little bit more about how they work. Talk about bytecode caching, how we have cold start prevention, all sorts of good stuff. I can link that as well. But yeah, Vercel functions is where we run logic like your API routes, your server rendered pages, you stream responses, you revalidate content for ISR, you securely connect to a VPC inside of your AWS instance with secure compute, you do OIDC to prevent having to have hard-coded keys into your AWS account. You can use that on Vercel to make that connection into your whatever cloud you want to use, AWS, GCP, Azure, and so on. And application delivery is kind of the broader category of how we think about this life cycle of request. And we want to make this as smooth as possible. That is what happens when a user presses enter on a Vercel request. Ta-da. Da-dum. And now we can talk a little bit more about specifically the edge network. We can go into more bits here. But again, I will pause, see how y'all are doing in the chat. Again, one more time, if you have Black Friday, Cyber Monday deals, I would love to shout them out. Don't be shy. You can DM me if you want to, and I would love to give those a shout out. Okay, let's keep rocking and rolling. Life of a Vercel request, navigating the edge network. Who is it? It's Dan again, back with the bangers. Shout out to Dan. We've got all sorts of content to catch up to here. So this is a follow-up from part 1. We already talked about framework-defined infra. We talked about how it provisions cloud resources. But then at the end of the day, on your Vercel application, you incur some usage. And you might have seen these on your usage page. You might have seen these on your invoice. Things like edge requests and fast data transfer. And I want to talk through in this post kind of how those get accrued, how you can optimize those, and kind of how to make sense of how those metrics work. So these are very granular metrics that allow you to understand traffic through Vercel's edge network, and let's talk about them. So first, points of presence and a local first contract with Vercel's network. We probably don't, not to be confused with the local first movement of building applications similar to linear. Naming is hard. In our first post, we showed how each of Vercel's edge network components are pieced together. Now let's look closer at the start of that journey. So specifically getting into the edge network. So we're monitoring the health of all of the networking endpoints and connections to route your traffic to the most efficient destination. We talked about anytime routing. We talked about picking the best point of presence. And after we do that, we go through the firewall, we pick one of these 18 globally distributed regions. And if for some reason one of those regions was down, which, knock on wood, pray to the Black Friday, Cyber Monday overlords, things are going smooth right now, and hopefully it stays that way. After passing through the initial evaluation, if something did go wrong and you need to reroute to another region, Vercel can ideally take care of that for you in some instances when you define your failover regions for compute, as well as we have multi-AZ failover for your Vercel functions, your compute. Let's keep going. Let's keep zooming in, starting with the foundations of how Vercel transforms every request into edge request, and then we optimize delivery through fast data transfer. So when does a request turn into an edge request, which is something that you accrue usage of? Well, they get filtered first by our firewall, and we do that check first before it actually accrues an edge request. That means that if there is a system block from our system firewall, or you have a user-defined web application firewall action, some persistent action, then usage is not occurred. So usage is not incurred. So you're not charged if the system firewall is blocking that traffic, or if you've set up these custom rules that have a persistent action. So if you make it through there, if you make it through the defense, it's traffic that you want into your site, then that becomes an edge request. It has this clear purpose for fetching data, triggering an event, whether that's looking at the application, the deployment, looking at cookies, user agents, etc. These attributes shape how the request is processed and its bandwidth usage. So the client's next step, after a response is delivered. So then Vercel enriches requests with data like geolocation, environment variables, deployment or branch details in those edge network regions. And we have this application awareness such that you can do these kind of quick geolocation-based checks in middleware or in functions, kind of allowing you to do those real-time changes to your network. So every edge request processes data in real time, whether that's a static asset, a dynamic API route, or a server-side function. And this matters because it gives you insight into where usage is being incurred in your application. For example, you might have X number of edge requests to an HTML page, and you might have Y number of edge requests to some static asset like an image or a CSS file. You can view that breakdown. You can understand how you steer traffic in your application. So you can see all this in the usage tab. You can also just look at the network tab of your deployment. If you want to optimize, if you go look at the usage page, if you look at the firewall page, and you see something that looks off, it's like, wow, it seems like there's more edge requests here than what I would have expected. You can kind of drill in a layer deeper in the firewall and kind of see if there's anything in here that doesn't look right. So I'll probably talk about this more later, but I have the Vercel firewall here for my site. I'm just kind of looking over the past day, and there was some automatically challenged and then automatically denied traffic that Vercel's system firewall took care of to prevent DDoS attacks, and I was not billed for that usage. So if I go in here, let's say I click on this one to filter in, these two IPs look a little sus. I can kind of change the different information in here. Maybe I want to look at the specific fingerprint, which I can do. This one seems very sus. It's very spiky. I can go in and kind of make a rule from here. I can change the the filter. If something looks really wrong, like I just see a huge spike of traffic and I don't know what's going on, I can enable attack challenge mode and just automatically turn on this challenge rule to prevent kind of bot traffic from coming to my site. I can configure new rules inside of here, whether that's things like rate limiting and so on and so forth. Okay, fast data transfer, powering rapid data movement to and from Vercel. Not normal data transfer, fast data transfer. We're going to talk about why that is. This ensures rapid data movement between the visitor's browser and the Vercel Edge region. So not only do we have many different POPs in our global edge network, we have our dense regions, our dense edge regions that can have a higher cache hit ratio, but all of this network chatter, all of this communication happens over private fiber connections on high speed networks, and we kind of bypass the traditional public internet bottlenecks, so you can have this kind of secure high-speed data flow. One way to think about it is if you drive on the interstate, if you drive somewhere, sorry, non-US folks, we in the US we love cars for some reason, and our interstates are always packed with cars. So when you're stuck in LA traffic and you want to get past this massive number of cars that's just at a standstill, there's a fast lane. And that fast lane, usually it's like a carpool lane or you have to pay extra to get into the fast lane, but you get to skip everything because you have this unclogged, uncongested lane that's going to be faster. It's going to allow you to get to your destination faster. The fast lane on the interstate, that's kind of like Vercel fast data transfer. And all of the other lanes that are, backed up by the BART, like the public transit, that's kind of the general data transfer that you would kind of get out of the box if you're rolling your own on cloud infrastructure without some of the optimizations that we have. Fast data transfer is the low latency movement between data of users and the Vercel Edge network. So if you reduce the time to first byte and the LCP, the Core Web Vitals, which we have another post on the Vercel blog that goes really deep into Core Web Vitals if you want to learn more about that. Not only is that making your end user experience better, which is great, it also helps you reduce your data transfer as well. So this is measured by the volume of data transferred, both inbound and outbound. And you can view and inspect and debug this information on the usage page to try to figure out how you can optimize not only the end user experience, but also kind of draw down or reduce the amount of usage incurred in your application. Again, you can go check this out in your browser's dev tools. We also give you real-time usage visibility in the Vercel dashboard if you want to check that out. And another plug here, if you're serving images or videos, you really want to think through how you are structuring your application. If you have a bunch of images on your homepage and they're not being optimized and they're being routed through fast data transfer, that could be a lot of data transfer. If you have a 5 megabyte image, for example, that's not compressed. For images, I would recommend checking out image optimization. If you don't want to use Vercel's image optimization, you can always optimize images kind of during the build process of your app or use a third-party service. But it's important that you don't, if you have 100 images on your homepage, don't just throw all of those behind fast data transfer because it's probably going to be not what you're looking for in terms of incurring usage. Kind of same thing with a large background video that's uncompressed or non-optimized. Every time that gets loaded in the browser, if you're loading a 20 megabyte video that's auto-playing, that's incurring a lot of usage and a lot of data transfer. So we have some guides on how to do images and videos well on Vercel if you want to optimize that a little bit further. A look behind the scenes of requests. You can look at the X Vercel ID header in your HTTP responses to understand a little bit more what Vercel's Edge network is doing behind the scenes. So let's say you're in New York, you're going to get routed to the nearest Edge region, which is IAD1, Washington, D.C., aka US East in AWS terms. We have a function here that's executing in SFO, San Francisco. So that's probably where your database is. And that's due to the proximity to your backend origin, aka database. So your ID might look something like this: Edge region, function execution region, and then some unique string so that you can kind of fingerprint this. And also if you submit a support request, we can help dig into the specific case that you're seeing. And that's pretty much it. That talks a little bit more about navigating our edge network. Another blog post down. By this point, you're an expert on the Vercel edge network. You know more about it than me. You can go navigate our firewall. You know how the usage is incurred. You are just so knowledgeable. But there's more. We're going to talk about more. I'll pause. I'll pause to check the chat, see how y'all are doing. Drop a message where you're tuning in from. If you have a Black Friday, Cyber Monday deal and you want me to shout it out, you're on Vercel, you're an indie maker, or just a hobby user, let me know. I'd love to check it out. And yeah, we're just hanging out here watching this live counter of the Black Friday, Cyber Monday site. And we're going to talk a little bit more about how it's built as well. I'm sure some of you are curious about that. And yeah, I think, let me, maybe we'll pause here for a second. Let's pause here and talk a little bit more about how the site is built, because I think that could be fun. So we'll reload the page here. See that nice booting sequence. That looks great. I see there's one comment here. What's the site? Oh, that's in reference to other Black Friday sites. Never mind. Okay, let's talk about how this site is actually built and some of the kind of interesting things here. I think one of the big things that has made this really smooth and kind of helped, I guess, simplify our Black Friday experience of building the site is we wanted to roll this out in a way that would kind of minimize the impact on us all having a long weekend. And there's some things built into Vercel that make this really easy to, one, help us get kind of predictable performance and not put a heavy strain on our backend system by default. And then some other bits that help with optimizing availability and reliability. The first one that I'll talk about is instant rollbacks. So let's say we're tweaking something on this page and we mess something up, something goes wrong. One of the nice things about Vercel's infra and the fact that for each immutable change you make, you get a unique URL. Not only can you preview that change, which is helpful if you want to send that to your team, but also it allows you to very quickly, instantly roll back to a previous version of your application. If anything goes wrong, you have the ability to kind of flip between the different versions of your app in a quick way. Where you don't have to spend a bunch of cycles on setting up that kind of CI/CD infra yourself. So that's one big thing that's helped us move quickly. The other one is SKU protection. SKU protection, let me, version SKU. So Malta has a good post here. Let me see. Malta has a good post here talking a little bit more about version SKU. Basically, if you have a distributed system and a browser, a client is looking at this version of the application right here on the left, and then you deploy, you take the new version of the application. It's got a new ID, a new hash, and you put it in all of the edge network regions. Well, what do you do with the previous clients who are trying to connect to APIs or fetch backend instances like the JS bundles? Most apps, and this isn't a Vercel thing, this isn't an XJS thing, this is just a general distributed system thing, is you're going to have this version SKU, and it's kind of hard to build a resilient system against this. You can of course say, hey user, just reload the page, which yes, that does work, but ideally your applications can be kind of fault tolerant against this. So one of the things that we've built at Vercel that we're kind of uniquely able to do because of these immutable deployments that I talked about is put in a default SKU protection. What this means is on the left, if I'm on this version of vercel.com/BFCM, our Black Friday Cyber Monday dashboard, and we deploy a new version, but I'm still polling, I'm still making requests to go get more data about the request per second. If all of a sudden the live production version of our site updates and it's no longer version 2, it's now version 3, Vercel is able to know that it can still kind of take this ID of the deployment and route those requests correctly to the previous production deployment. So you can have kind of multiple instances of your application in parallel such that those older clients on the outdated version don't experience this version SKU issue where they see some kind of 500 error trying to access a resource that no longer exists. So SKU protection gives us a lot of confidence that we can roll out changes quickly without breaking existing clients. That is on by default for Vercel sites, and it's great. So that's one thing that's been huge. Another thing for this site that has made, I think, me sleep better and probably others sleep better is we're using incremental static regeneration. If I go to our docs and let me just search for incremental static regeneration. If you want to learn more about ISR and also, see how to use it, I think the key section here to talk through is how this is different from cache control headers and why this is a really good strategy for what we're doing here. We want to ensure that even if our backend went down, we could still serve a previously generated version of our page. And one of the things with cache control headers that is kind of tricky is that they are not durable. So when you cache something, it's going to get evicted. And you can, of course, configure that time when it gets evicted, but there's no guarantees over a cache. It's kind of fleeting by default. Now, if your backend goes down or if you have some intermittent connectivity with your API, that's going to be a problem when you're then trying to pull and get information from the live updating counts here for deployment and requests and firewall activity. Ideally, you can have that fallback guarantee that there's a previously successfully generated version of your page in the instance that there was some connectivity or some issue. Not only is that generated page cached, so it's not a or, it's an and with caching. Yes, it's still cached, and you get to put it into durable storage. I think that's huge for reliability, and it really helps us sleep better when building experiences like this. Let's see, what else? Another thing that has been really helpful for this site is that we're able to experiment with different versions of this page through middleware. And we also were able to toggle on this entire experience as part of the broader site. This is on the main vercel.com. We're able to toggle on this experience using feature flags that are integrated into our toolbar. So this toolbar right here, you can click on feature flags. You can go look at this flags explorer, and we were able to actually turn on specifically the Black Friday, Cyber Monday flag when we were testing, sharing this with others internally at Vercel to figure out if everything looks right on all devices, kind of in production, instead of having to do that last minute deploy where you just cross your fingers and hope that everything works. So really think that that's a key thing that's very nice. Also, we can build out these kind of separate micro front-end experiences in different apps in our monorepo and then connect them together. For example, the Docs app is a separate app from the main Vercel dashboard, but it's stitched together and you can kind of prefetch pages across micro front-end boundaries to make it feel like a kind of unified single experience, which I think is pretty nice. I think that's kind of mostly some of the big things on how this is built. Another thing, if you haven't heard of it, we recently announced a new feature for Vercel Functions called in-function concurrency. What this is going to do is if your workload is primarily very chatty over the network, you're doing a lot of network I/O, you can send multiple requests into the same function. So let me go to the Vercel blog, and I will find our serverless servers post. It's in here somewhere. There's too many blog posts, which is, I guess that's a good thing. Too many blog posts. Serverless servers. I think there's a good diagram in here. Yeah, so in traditional kind of serverless function models, it's like, hey, I'm running some compute, but then I have idle time, and then I'm running some compute, and it's like per one request response. Ideally, you want to be able to send in multiple function invocations into that same instance, making it more concurrent. Ultimately, what this means is that as an end user, you save money. That's less money that you have to spend on function duration or gigabyte hours where your functions are running. And funnily enough, it also helps performance. You're going to have higher cache hit ratios or higher warm hit ratios for your functions because you're keeping those hot. We also have cold start protection on Pro plan. So the chances of you hitting a cold function with a paid Vercel plan and in-function concurrency is now very, very, very small. And you can monitor all of this in the Vercel dashboard in a new tab for in-function concurrency that shows you cold start rates, shows you how much gigabyte hours you save on in-function concurrency. And it looks something like this. It's a very nice dashboard. I think that's pretty much it on how we built the site. Of course, it's got a very beautiful design as well. Shout out to our design team. But if you have other Well, somehow my audio cut out. I just saw the chats come in, but I think that I probably missed the second half of this blog post. But thanks. I saw the chat. I should have paused earlier to see what it was. Sometimes OBS just decides to pause me for some reason. I don't know why. Maybe it's a skill issue. Anyways, what I was saying was that persistent actions for the firewall make it such that if you see somebody being malicious and you don't want any subsequent request that they make to incur usage on your site, you just put on a persistent action. You can think about it like a penalty box or some timeout window. And that means that you're not incurred usage, you're not charged for any of that malicious activity that they try to follow up with. For example, you see somebody from one IP or one fingerprint that is clearly malicious. You slap on a persistent action for, I don't know, let's say a day, and you say, any additional attempts or requests that they try to make to my site, I'm not going to get charged for that. We're just going to immediately block them out. So that's a really nice feature to have built in. Last thing that they heard was in-function concurrency. So I don't think we cut off too much, hopefully. The general gist of what I wanted to get out of this post is just to mention that if you want to not get charged when there is somebody incurring malicious behavior, slap on a persistent action for your user-defined firewall rule, or do a rate limit as well. I have a rate limit on my site, which is very helpful to have. You just don't have to worry about it. And let's do a little demo. Let's check it out. So leerob.com, got my site here. Let's go in and configure a rule. I've already got the rate limit on, which I don't remember what, 500 requests in 10 seconds. It'll just get rate limited. But maybe I want to do a new rule like if request path equals... this is a good test because I'm not sure how this one works. If I put in a route that is a 404 in my framework defined, code, I don't have a test path. My assumption would be that this gets evaluated before in this logic in the firewall based on the life cycle of a request. So if request path equals /test, let's challenge it. And this is the persistent action bit that I was talking about. In this case, it's fine. Testing, sure. So now it says, hey, you want to review these changes, make sure this is good. Yes, we're going to publish this change and it's going to propagate these changes to our firewall kind of globally. So now if I go here and I go to test, well, there you go. So first, before we ran the framework code, we saw the challenge page. And this goes back to that lifecycle of request. That's being evaluated before we get to that part of the request lifecycle. And then we continue on and we get to our 404 page. If instead, we didn't want this to be a challenge, we wanted it to be either just log it out, deny it, or something else. Let's do deny and go in here, publish this. Again, I'll go to test. And now this time, it's already propagated globally. In every edge network region, all of these kind of custom WAF blocks over here on the left, this is what this is. The system challenges was the one that we showed before that the system is automatically doing, but then the custom rules that you can define, you can kind of publish these and ship them out in about 300 milliseconds and kind of block malicious traffic to your site very, very easily on kind of any defined rules that you want. So yeah, I think that's huge. Can you temporarily disable the firewall for load testing? So generally, you shouldn't need to load test on our infrastructure. Sometimes folks still want to do that for kind of peace of mind, but I usually recommend against it because you probably want to reach out to us first if you're going to try to send a large amount of traffic, because our system firewall is going to see this anomalous request. And if it's over, a normal threshold, we don't want you to accidentally block your own load testing traffic. So it's always better to kind of reach out to us, start a conversation around that. But also part of the reason we provide infrastructure that kind of scales automatically and without supervision, it's not something you have to kind of manage yourself, is so that you don't need to worry about that. But I still understand that some folks still want to do that for whatever reason. So I would recommend reaching out. So I'm going to go in here, delete this rule, and publish this change. And we're going to go back to here. And now instead of getting blocked, we just go back to the 404. So that's gone now. That's just like a quick demo of the firewall. I'll clear these out. Anything else on the firewall you want me to show? I'm more worried, follow-up question on the load testing. I'm more worried about our database performance than the pages themselves. So one thing that you can do, I'm trying to think of a good example here. Let me go check. We're going to go look at the Next.js website. And let's say I'm looking at the docs page. One thing that you can do in our upcoming observability view, if you're already using monitoring, you can check this out. But you can see your requests to external APIs, and you can see how long they take. So nothing there. Maybe we have some here. Yeah, so there's Koala here, Tray. You can kind of see how long they take, the number of requests, the error rate. That can help you identify if there's kind of bottlenecks in the system or your backend is not performing in the way you think it would. Is you have that full visibility here in your observability view to see, we can even dig into more advanced numbers like invocations, error rate, CPU throttling, memory usage, time to first byte, cold start time, all sorts of good stuff there. The Next.js site probably isn't the best example here because this is basically a static site with very, very infrequent ISR updates of the docs content. But maybe I have another one that's a better view. I'm not sure. Hopefully that still answers your question. Let me go back to the chat and see if y'all have any more questions or if there's other blog posts that I should dig into. Nothing I can see right now. Okay, anything else you want me to cover, or do we all just want to kind of collectively sit back and marvel at the numbers? It's beautiful. It's now bigger, so we can just really take it in. There's something very satisfying about just watching the count trickle up. And now that you have a better understanding of our edge network, of our firewall, of kind of how requests flow through the system, I think it makes this graph so much more interesting to look at. Like if I'm a visitor here, for example, my request is getting routed to one of those pops, points of presence. Then it's going to our dense edge network regions, like France here. You can see the requests per second, the total requests. That's where you can have your edge caching. That's where you can then kind of steer your traffic to go talk to your origin region. So maybe that goes over here to US East, IAD. This is your origin region where you're running your compute. So you've got some network chatter here between your database and your Vercel compute. And then boop, that goes back over the ocean and it goes back to your visitor somewhere near France. So I think that's pretty cool. It's helpful to visualize it that way. Okay, well, I think that is pretty much everything. We talked through how the edge network works. We talked through the firewall, the web application firewall, custom rules. We read through some blog posts. We talked about how the Black Friday Cyber Monday site is built. If you have a site on Vercel and you're running a Black Friday Cyber Monday deal, send me a message. I'm happy to amplify that and support your work as a kind of indie creator or entrepreneur. And Go to vercel.com/BFCM if you want to watch this dashboard live. It'll be running all weekend as folks are making purchases on this commerce weekend, as they're making traffic to Vercel, as they're kind of kicking off deployments and updating their website. And yeah, this was fun to talk through. Thanks for hanging out on this Saturday. Hope you're all having a wonderful Saturday, and we'll have a wonderful rest of your weekend. We're going to wrap it up here, and stay tuned for the next stream.